for anybody who's got a question that they want to throw out there. We're going to kind of chat a little bit about what do you do when you can't tell if your kids can do the engineering because they can't do the math. And so you maybe saw that a little bit in 1-1 with simple machines and you know, just the mechanical advantage, what was happening there. And so that's kind of your first indication that your kids have weak algebra skills if they can't handle those proportions. It's a good time to kind of identify who needs a strong partner when they're working in groups because their algebra skills are lower. Then, you know, electricity has a few things to figure out. They, again, it's kind of proportions. It's pretty easy equations to solve. Then you get into 1-3. You get into thermodynamics, and you're not playing anymore. Like that completely ups the ante, and that's when kids are seeing equations and manipulation that's equivalent to the work they're going to do in Algebra 2. So that's usually where my kids' math skills start to differentiate their ability to keep up with their peers at the same time. So at that point, there are a couple things that I do. One is way back at the beginning of the year, I asked my kids to do a PowerPoint presentation on what math class and science class they were in, and so that kind of gives me an idea of who's a strong math and science kid and who's not. And then when we're stacking groups, I'll create maybe 2 groups. I'll have kids who are drawing even numbers and kids who are drawing odd numbers. Sorry, lights went out. Kids who are drawing even numbers and kids who are drawing odd numbers. And then that lets me have, I'll have my evens and odds pair up by what they draw for their partners. And then I know that I have a strong math kid with a kid who maybe is not as strong. And that lets me have an extra teacher in the room for them. So when we're solving out problems and they're working together as partners, I have another kid who's teaching, kind of helping my weaker student. Because you are not going to make it around to the whole room in that situation, but it is a lot of before and after school and extra problems. I was talking to Adam, if you guys were in earlier, the second year that we had our program, we convinced them that the POE class needed to have a prerequisite of geometry. And so that kind of allows me to have kids who are Algebra 2 or higher. And so that has helped me avoid some math issues, maybe having kids who are in Algebra 1 or geometry. Because what we found was I was teaching trig before the kids were seeing trig. And so we had enough numbers that we could put that prerequisite on and still not affect our POE numbers. And it actually bumped up our IED numbers because we got more kids to take IED than while they were taking the prerequisite classes. Adam, what's your thoughts on that situation?
Yeah, I mean, if you have the numbers, POE was, you know, originally way back when was like the first class. Every kid comes in, takes POE, and then they found out, I think, very quickly that it's kind of a difficult course, especially for freshman level students. Though, you know, if you can get them to take it as a sophomore, or even some schools I know do it as juniors, I think it's a more successful class for them. But you know, sometimes you don't have that option. For us, we're the same way. We like them to go to IED first, but we don't require it.
You know, our principal, can you hear me?
Yep.
Yeah.
Our principal just put out a call, are there any classmen that the freshmen shouldn't be taking? And I actually polled my students. I'm a first-year teacher, so I kind of was clueless on this. And I looked at, I have 13 freshmen, 2 in POE, and then 11 in IED. And of all my 13 freshmen, I would say all but 5 are either low C's or D's. So they're just not being successful in these courses. And I don't know if it's the math or what I'm also seeing is the inability to like write down what they're doing and to turn things in is giving some of these students a bother. But I had actually suggested a bit of a math screen to perhaps at least maybe get those kids at the higher level that are ready for that, because I guess if you're not ready for geometry, maybe you're not ready for some of the independent work. Or the other thing, and I don't know how you screen for this, is there has to be some sort of a recommendation that you're a good team member and you can work independently, because I just have kids that, you know, they're able to do the work, but they just can't seem to turn it in.
Yeah, that's going to be a problem no matter what class you teach. It tends to be across the board. You know, some students just aren't going to care if they're failing. You know, some students are happy to come in and learn, but they don't really care to do the paperwork. But, you know, what I've found in the past with at least most students that I get, even if they haven't had the math, like you know, algebra 2 or whatever, it might be where they're getting the trig stuff. If they're good in math, then they usually pick up on it relatively quickly if you teach them. But if they're
Right.
bad at math in general, you know, I don't know how much of them even having the class would help.
Right. I agree with that statement. It was like what Adam and I were speaking before class, if anybody was there. The thing you have to be careful of is not to filter your class to the point that it doesn't make. And so we are, at least for Adam and I, we are elective classes. And so I also happen to teach math classes at my school. And so it's a different deal because you're the only, you know, you're only restaurant in town, so everybody's got to eat there. And so as a math teacher, I'm not worried about what numbers I'm going to get in that class, but as an elective teacher, you have to have this balance of them getting stuff out of it, and then still the reputation is that people want to take your class. POE kind of does that for you a little bit on its own just because the projects are so cool that that kind of helps, is that the kids talk about to their friends about whatever they're making and things like that. I have display cases out in the hallway where we store all of our stuff intentionally as an advertisement. So when kids walk by, they're like, oh, that's cool. I wonder what class you do that in. And then a great big sign that says Principles of Engineering on top of it. So, I think there's that fine line between who you want in the class and then making sure that the class makes. So the only thing I would say about, kind of putting some recommendations and some restrictions is if you got the numbers to do that, that's awesome. But if you are worried about your class making, then and so it's a balance. It's this fine line that you walk. I mean, you have to keep the legitimacy of the class. And so the end of course exam is going to have the math problems that you see in the curriculum. And so it's just that balance. But I agree with Adam, when I didn't have kids, I had some kids who had seen trig and some kids who hadn't, I would have like a secondary activity for some kids to do, or I would have an activity where, the kids who knew trig's responsibility was to teach it to the kids who didn't. And so it's a little bit of a sticky wicket. You hope they do it right, but it's kind of that, how do you get kids from where they are through what you've got, no matter what. And maybe if you're around long enough, you can start putting some requirements on. But again, it's just that fine line of, am I going to have enough classes? For me, I'm not going to not get to teach here, but I do want to have enough POE classes that it continues to make. Anybody else? Bill, I don't know that we answered your question. I don't know that we have a lot of magic for that other than, you do sometimes have to stop and start talking about how do you solve an equation. And then you can go back to the question at hand.
When I did a survey of the IED kids, though, only about 5 or 6 of them did not have geometry. There were some that were taking it concurrently, and some of them were taking it, they'd never seen it before. But, I mean, in that circle, you're talking about circles and tangents, and, I mean, for them to not be able to know equations of spheres and stuff like that is, golly, I mean, it just kind of blew me away. But there was a very small amount that had never, like 5 out of 30. and then another 5 or 6 that we're taking it concurrently.
Good.
Okay, anybody else have another question out there? I know that Adam and I, we acknowledge your situation, I guess. I don't know that we have a lot of solutions for some of that other than we too have lived through it. You know, and maybe, the activities that I find kind of depends on my kids. You can find anything on the internet. So like when you want to, you know, do a trig activity, I'll, you know, just in a search engine say, practice with sine, cosine, and tangent, and then I'll say worksheets, and then, you know, it'll actually give me those. So that I kind of just, you know, search engine the topics at hand that I'm interested in, then just kind of sort through them and see what I've got. Okay.
All right.
Well, Adam, you want to let me take over screen and I'll finish up the PowerPoint we were in. Okay. Everybody think good thoughts. Let's see if I can pull this off. We were in this. Everybody looking at an ultrasonic rangefinder?
Looks good.
Awesome. Love it when technology and I are on the same page. So this is the PowerPoint that you find in Activity 311. And we had talked about kind of the hardware. We were just, and you know, the fact that they are well versed at these parts, right? So this is all stuff that they have seen. This is where you're going to get into the new stuff, the motors and the controllers and the servo. And we started to talk about the different kinds of sensors, you know, all the red stuff that you had in your kit. Potentiometer, again, big warning. These get broken all the time. And then if you break one, you have to buy it. So again, my rule is on the potentiometer that you cannot attach a potentiometer to an axle that is directly attached to a motor without clearing it with me. And that's just helped us not kill quite so many annually. So I think we kind of stopped talking, we stopped here where we were talking about the rangefinder and the motion sensor here. This is kind of a moderately used sensor for my kids. They do use it sometimes when they are maybe building an elevator or they want to control how far something moves. Sometimes they'll use this rangefinder when they're designing some of their different builds that they have to do in 316 and 317. So the Cortex, this is a $250 item. So this is a great big deal. You don't want to leave these out where they might accidentally get taken. And often I say this to the kids, I'm like, somebody doesn't take a VEX part because they know it's a $40 item or whatever. They take a VEX part because it's cool to play with, and then they don't even know, you know, that they're stealing something, that like this thing's worth $250. But this is really the brain that allows the hardware and the sensors to communicate with your computer. So be super gentle with these guys because they are really the expensive part of all of this. It would take, I mean, I get class fees, but each class I have is a little under $250. So all of my fees for an entire year for one class will purchase one of these Cortexes. So they have a little plug-in spots on the end, and each of the sensors and motors have a 3-pronged wire here, or a converter to do that plugs into these ports. It's a flashlight, has a 2-line. So those plug in there. Adam's going to show you some setup stuff with that today, so you can see where those go. There are 12 digital ports. Those are the things that have either an on or off reading, like a button switch, things like that. There are 8 analog inputs. Those are things that have a range of values. That would be like the sonic rangefinder. That would be like the something that had like a potentiometer. And then we've got 10 motor ports, and this is where you're going to put your motors, your servo, and your flashlights. So this is kind of where you go to the activity, and I'm going to go ahead and talk a little bit about a document. And I sent you guys this document earlier, not that much earlier tonight when I was pulling it up, and I found one thing that I changed already because I've not used it yet this year. My kids are a couple weeks away from this. But I kind of turn my kids loose on several parts of this activity and kind of have a timeline that every class day they should complete one of these activities. And if they don't complete them, then they know that they are behind and need to come in before or after. But I had one of my aides one year go through and kind of write up what happens in Activity 311. So in Activity 311, they have to make a test bed. They go in and add the motors and the sensors using the PLTW template, and then they test all of these things. So how does the line follower work? How does the potentiometer work? How does the light switch? And then how do these servo, flashlight, all of these things work? And they should have in their notebooks the notes from this PowerPoint that we are going through, or I was just going through with you. And so often I can't get around the room and say, oh yeah, you're done with each little part of this. So what I ask the kids to do is save these programs, and then I just kind of walk in a regular pattern. They know the kind of figure 8-ish that I walk. And so they are to, each time I walk by you, if you need me, that's your time. And you know the pattern I'm going, so you can kind of see where in the queue of getting help I'm going to come back to you. But they save these programs, and then I can walk around and say, do you have anything you want to show me? And they can pull these programs up, and I can ask them questions. Like, they should have in their notebook information about the line follower, the potentiometer, and the limit switch. So different values that they wrote down as they were going through this. And then in 312, there is a PowerPoint I'm going to show you here in a little bit that's a flowchart PowerPoint, but I do that with them. So I don't have that here, but if you wanted them to do the flowchart PowerPoint on their own, you would just take and insert one of those boxes. But this kind of tells me all of the little programs along the way, and anytime there's this blank, it says within the activity, have your teacher, show your teacher this. And so this is where I ask them, every time you see a blank, you don't have to raise your hand and make them do it, just save that as like 312 part 1. And then they modify it and they call this 312 part 2, part 3. And so I can walk around and have them pull those programs up, show me those programs. I can ask them specific questions, and I have a sense of what I'm supposed to ask them, because this kind of gives me a little bit of a feeling as to what's happening in each of those programs. So I know that they're supposed to have these notes. So each of these activities are posted on my school website, as is the PowerPoint, so they know, like, today this is what you're supposed to be at, and some groups lickety-split fly through them, some groups don't. I tell the kids that are slower at working through that they should have the PowerPoints done as homework, and then they can come straight in and just work through the programs. My kids that kind of get ahead, if they want to sit and watch the PowerPoint and take the notes during class, they can. I will say I did, since the one I showed you, this PowerPoint was up by 312, and it's actually in assignment 313. So I drug that down. So that's a modification you might want to make. But this just lets me kind of have some documentation as to where they are and what they've done, and it lets me kind of walk around to kids who are, all in different groups and different spots, and be able to ask them a question that's intelligent for where it is that they're at. So, so that's kind of what that document is that I sent you today. So that's
so
where
this says add motors and sensors to sample details of unit template. What is that?
Well, so they have, like in this opening in 312, let's say, they open the template and they configure this, the project, the activity tells them to go through and do this. And then they copy a program from the assignment and they put that in. And then it'll say after that, stop and show your teacher. So they'll save that as part 1. And then they'll go in and modify that by having it run the right motor for 5 seconds and then it stops. And then they modify it so the left and right motors run, and then they modify it again so they reverse both the motors, so they go clockwise and they go counterclockwise. And so the activity is telling them to do these things, and then it'll say every once in a while, stop and have your teacher show your teacher, or have your teacher initial. I forget what it says. But this just is a stopping point. So every time they see a break, they know to save that program as 312 part 1, 312 part 2, 312 part 3. And then when I get to them, if they've got that done, they can call that up and show me those. And I can just talk them through and mark them off on that. So each of these things are just heads up for me, so I know what happens in program 312 part 3, so I know what I'm looking for when they're running those programs. So Patricia, did that answer your question?
Well, not really. So I have the Fisher Tech, and so what I did is I pulled down the 3.1.1 and the 3.1.2 and the 3.1.3 from the Fisher Tech. And I guess it doesn't have any template program, so I guess that's a little bit differently. But it sounds like I just need to hook all this stuff up and work through the exercise and see what happens.
Yeah.
Yeah, you do. And theirs don't have the Fisher Tech. It's been like 7 years since I did those, but theirs are going to have more just end results. So 311 probably doesn't have as many parts. It has one set thing that's supposed to be done by the time you're done with that. So when I used Fisher, I didn't use this outline because it was much easier for me to tell whether they had finished each of those activities than in the VEX. So this organizer kind of came about when I moved to VEX because it has the programming is just more legitimate, and so there is more program learning in the VEX and Robot C than there was in the Robo Pro and the Fisher. So yeah, so this does not match the Fisher technique. Nothing that I have does, including my tests or anything.
No. And I guess, so where is this unit going? This unit is just introducing them to programming and turning lights on and off and potentiometers on and off and a little bit of that stuff.
It's yeah, this is a control system, so it is teaching them some programming. So if your kids are interested in computer hardware, software, it's certainly teaching them that. It's teaching them some programming structure. If you're using Fisher, you'll be using RoboPro, which is not a coded language, it's an icon language, the way that we've used it. And so your kids will be more versed in flowcharting because that's how that language looks, because it's an icon drag and drop, versus the Robot C that the VEX folks are using, and they will be seeing language. I can tell you that there are, last time I wrote questions for the end of course exam, I was assigned the control system unit was where I was assigned to write questions, and I had to write questions that included flowcharting skills, and I had to write questions that included program language skills. And we left the program language pretty generic. It wasn't exactly Robot C that we were using, but it did include, you know, the ability to understand a while loop and an if statement and an until statement, and being able to follow a language and structure of coding. So really Unit 3.1 is about control systems, it's about coding, and the VEX or the Fisher Tech is really just the ability to see, did that program work? So you're just learning a language, and the hardware component of it is just the confirmation that your coding not only didn't have any bugs in it that came up when you tried to download your program, but it also actually did the thing that you said you were writing the program to do. This is one, for my kids, this is one of the hardest and one of their favorite units, is the marble sorter and the languaging. And my kids, I've had a drop in the number of my kids that actually have programming skills. So since I've been teaching it, that gets lower and lower every year. I'll maybe have 2 kids in a class of 26 kids that have any programming skills at all. So it's a good sense for them to just see how to program.
And where is the marble sorter project?
That is the last activity in the unit. It's
332.
Adam, is it 332?
Yeah.
312? Is it all the way 332?
Yeah, because the 317 is the
little
projects or whatever, and then the very end of Unit 3 is the problem, which is, I guess they coined it a trash sorter.
Yeah,
We end
material sorter now.
Yeah, we end up always calling it a marble sorter because you're sorting different materials, but they're all marble shaped.
Yeah. And so that's the very end of Unit 3, I guess. So that's kind of where it's all heading.
So Unit 3.1 is really where you have the controls, and then it looked like you went into 3.2 is
Fluid power.
Fluid power.
And then 3.3, is that just the problem?
Correct.
Yep.
So that's just because with this project lead, you have to dig down, and then there's really no overview, so it's just the marble sorter.
Yeah, that's the design. That's the design problem.
3,
So
2, 1,
here I'm back in the modules. So Unit 3 control says Lesson 3.3 design problem marble sorter. And look, Adam, they called it back marble sorter. I will say one of the things I miss about Fisher Tech is I used to love the fluids parts that I had. They have an awesome air brake activity in the Fisher Tech stuff that is not in the VEX. So
you can buy it, but it costs.
It's really expensive, and I never know if fluids is going to stay in POE or not, so I haven't purchased it yet. So I'm going to wait until the new rewrite comes out in another year or two. But yeah, 3.1 is really about learning the language and learning programming structures, and really the VEX or whatever the hardware is just, it's like I told it to, turn the light on. Did it actually do it? It's pretty, I mean, I have a computer science minor, and sometimes just the fact that it counted to 10 was pretty exciting, if that was your goal. It does have fluids in there in 3.2, which if you are, this is a little weirder fit for VEX now, but yeah, that is the next, and then you'll go on to the sorter. I put my sorter at the end of 3.1 actually, and I don't break it up with, I don't put I do 3.1 then 3.3, and then come back and pick up 3.2. Since we've moved to VEX. When I was back with Fisher, I used to do it the order that it's here. But that's where all that is.
I was going to say now with VEX, we don't really have the fluid power stuff to incorporate into the design. So
right.
With the Fisher, you could have pneumatic components if you wanted to or not.
Right, and not quite as, we don't have that set now. So yeah, I go 3.1 then 3.3. So that's what that Word document is for anybody who's using the VEX stuff. So that's there. Adam, do you want me to keep going in this, or do you want to jump in and show them the robot stuff, or do you want me to run through the rest of this?
Might as well just, yeah, finish this up would be fine.
Okay, so this is where they can return to 3.1. But just kind of talking about the software. So hopefully you have got your Robot C loaded. You at some point somebody in your world got a license code, which is how you get to load the Robot C onto your computers. That's a little bit of a moving target in my district. Sometimes I get that, sometimes tech people get that. So I always try and be way ahead of the curve on, do I have a functioning Robot C or not? Make sure my tech people are well aware about 3 weeks at a time that I'm going to be starting Robot C soon. I like it because it is based on C++, which is a language that I think is tried and true, has really held its own for a really long time. This is all the places that, kind of use Robot C. But you will, Robot C, in the time that I'm using Robot C in that month time, there'll be 2 or 3 updates. And so one thing that you need to know is that some of the documents, the PowerPoints, don't match the newest version of the Robot C page. And your kids are probably will accept this better than adults do. Sometimes we get hung up on the fact that it doesn't look exactly. The kids are like, yeah, that's close enough, and they just click on it and move on. But so it does kind of talk to you about what the pages look like. This is going to be, I think, one of the things that Adam's going to show you looks a little bit different when you pick your platform type. I don't think it necessarily looks like this. I haven't looked this year, but
Yeah,
my guess is that it's just a little different. Adam will show you that. But ultimately, your goal is natural language. We can find that. There are lots of sample programs, some of which your kids will cut and paste and copy in there. I am pretty serious about the programming side of it, and I think that's probably a little bit. I programmed for Sprint for a little while between my undergraduate and my graduate degree, and so just I think that experience for me as a professional programmer really makes things like pseudocode pretty important. So comments, this comments card you see here is pretty important when we start talking about pseudocode, when we start talking about flowcharting. That will become, I'll kind of emphasize what I do with that. I think Robot C has a great help page. I think that's one thing that has really improved in the time that we've had it. Your kids can go Google almost anything they have a question on in Robot C. And so I think that's not a terrible idea. I think that's a good resource. They can grab some code or see some code or get an answer to a question. There's some good Robot C forums. There's also a good help page within the Robot C itself. I was talking a little bit ago about how RoboPro, which is the old language we used to use when we used Fisher Technics, that was icon-based, and it was really a drag and drop, and that I like the fact that we are doing more coding now, but we still drag and drop a lot of our coding. So don't worry, it's not a blank slate. It's got some real structure to it, and Adam will show you that. There's some menus. Adam will talk you through how to choose which one you want to be on. This motor sensor setup, we'll talk you through that. That's how you get the computer to know what you plugged into that cortex, that brain I talked about. How does it know that you plugged in a motor? How does it know that you plugged in a limit switch? And this is in motor sensor setup. If I got a kid who's got their program's not doing anything, I'll often say, did you tell the computer what you have? Did you do motor sensor setup? And so that's easily forgotten. So how do you download it? Adam will show you a couple different ways that you can download and save and get your computer to acknowledge that you have changed some of the program. Often my kids will make changes and they'll forget to re-download it so that the computer knows the computer and the cortex are communicating with each other. There are some color codings. Anything that's green, the computer actually doesn't read. It's like it's not there, and that's because it's been put in some comment code, and that's just for human communication, not for computer communication. But the colors do stand for different things that's happening. And so you'll get used to looking for a particular color when you know something needs to happen. Okay. Do you want me to do flow charting, or do you want to go straight in?
I can take a look at Robot C, and then we'll come back to flow charting.
Okay. Can you take over the screen again?
Yeah, will do. All right. So with your students, oftentimes I like to go through that initial PowerPoint just to kind of get them familiar. At this point, they've already used the VEX components, so they're kind of familiar with the parts and pieces, but they haven't used any of the sensors or the motors. So those are like the really new things that they're incorporating. So it's nice to kind of go over them and talk about how we control them as far as the different values that we have to either input to turn the motors on, or values that we would read for some of the sensors. But what I do with the students is every time before we start up Robot C, I have them go through kind of like a checklist of things to make sure they're set up. So one of the things, Robot C here, this screen that you see right here is what we call a splash screen, and it's kind of annoying. It's nice to see, it gives you the firmware and the version, all that type of stuff that you're on. But for some of the students, they're going to be opening this program up and several times a period for several weeks. So it's kind of annoying. But what you can do is you can get rid of that screen. So if you go up to View, and maybe you want to make note of this, but if you go up to View and down to Preferences, it allows you to change some of those initial preferences that come preloaded with the program. One of the things that I do is I uncheck the Show Splash Screen thing, because to me it's just a nuisance. When I'm going back into Preferences. The other thing that can happen is when you either compile the program, and what that means is you ask Robot C to check to see if your program is worded properly. Whenever you do that, it'll automatically save the file. Whenever you compile and download the program, it'll automatically save the file. Or if you were to close the program, you can have it automatically save the file. So there's different things here that you can check based off your preferences. I don't like it to save every time, so sometimes I uncheck that in order to avoid some accidents. It's really up to you, but it's just a way of changing the preferences here. All right, so besides just getting rid of that splash screen, which is really just a personal preference, what I have the students do is I kind of have them check off these 5 things to do to check each time when you're starting up Robot C. One of the first things that they'll do is go in and they'll connect their Cortex to their computer, and they're going to update the firmware on the Cortex. So the Cortex, again, is that brain, the place where we're plugging in our devices and we're able to store a program and run that program. We can even run it without it being connected to the computer. But there's 2 chips on that Cortex that have to be updated. So there's a Robot C firmware, and then there's a master CPU firmware. So you have to run through the process to update that. They also open up a template and save the template. If they don't use the template, there's going to be problems with their program. So it's really important that they use the template, which I'll show you here in a second how to get to. They need to make sure they check their platform type, make sure they have the correct library, and what I mean by that is what language you're using, and then also set up their motors and sensors. So I make sure that every time when they open up that program, they've done these 5 steps. Now, you don't have to update the firmware every time. Usually it's once and done, but it's good to check just to make sure that you're connected with the Cortex, you're talking with it properly. Okay. So they'll open it up.
I think it's probably worth doing every class period. I mean, you'll circumvent so many issues if you just do those 5 steps. If you just say, have you done those 5 steps?
Yeah.
That's kind of masterful.
Yeah, they get familiar with them after the first day or two. You'll come over and they'll be like, I don't understand why when they compile the program, there's 1,000 red X's on it, then they're like, well, let's look at your language. Oh, you have the wrong language. So it's those easy things that usually can be solved just by them making sure they check those steps. Karen talked about earlier about the different, firmware versions that they'll put out. What I like to do is, I teach blocks. So I have POE first semester, POE second semester, and I'll update and I'll make sure that the Robot C is running on every computer to the latest version as of usually 2 or 3 weeks before we start doing that section, just in case there's any problems, I have time to fix them. And then if there's any new versions that come along in between that unit, I don't worry about it, unless it's some sort of critical update, which in the past usually it's not. It's just a new version. If you're downloading and updating the versions in the middle of the unit, it tends to be problematic. So I try to wait until we're done the unit, and then I'll update it for the next section. Right, so built into Robot C's subfolders, they have actually a whole bunch of sample programs and a template that we're going to use. So the students will go underneath File and say Open Sample Program. And here's where it can run into a problem. If they don't have access to the C drive, sometimes it won't let them get to the folder they need to get to. And in that case, all you have to do is save this file onto a flash drive or onto another site where the students have access to it. So, if they do have access to it, you're good to go. If they don't have access to it, obviously you're going to have to save it and provide it to them in a different location. But they should, when you open it up, it should say Sample Programs Vex 2. And then you just need to scroll down to Project Lead the Way, the LTW. You'll see that there's a template and a backup of the template. Because the students have access to the C drive or access to this folder location, if they save their file, they'll actually overwrite this template. So when the next student opens it up, it's possible that it'll be that program. So it's good to have this backup around our handy if you have to, give them the blank template again. So open up the template. What's nice about this template is it provides us with a good form, or format, things that students need to accomplish each time they start a program. I don't really worry about this top part too much. If they're working individually, it's not as big a deal. But the task description, the pseudocode, and our actual program down here are, the three really important parts. All right, so we have our template open. Let's pretend like I checked the firmware. I don't have a Cortex right now, but if I were to check the firmware, I would go up to Robot, then I can go to Download Firmware, and I can say automatically update Vex Cortex. And what you're going to find out is that's probably the hardest thing that you're going to do, is to make sure that every computer can connect and talk to the Cortex. And what we're going to find out is it used to be horrible, and now it's just annoying. So it's most of them are going to connect first try or second try. Sometimes what ends up happening is, for whatever reason, one computer will just not connect with that Cortex. So what I usually do is I just go to a different computer, get it to connect, and then come back to that original computer, and usually it works just fine. But what ends up happening is it's going to check to see, first off, does it need to be updated? For some of them, if it was updated yesterday, they'll say everything's good to go. Say that connection's good. For other ones, it'll automatically update. And again, there's actually 2 chips on that Cortex. So when you're updating the firmware, you're updating it for Robot C as well as the master CPU. And there's a lot of tricks of the trade that usually get this to work. If you're having problems getting this to work, let us know. We can kind of walk you through a couple of things that we do to get that firmware update. All right, so I've updated the firmware. I've got the template. Now what I need to do is make sure I have the correct platform type. And we're using the Vex 2.0 Cortex. The documents that the students are going to go through is probably going to have like Vex Cortex there, and then Vex IQ or something to that effect. But what they're going to see is just what you see in front of you right now, is just the Vex 2.0 Cortex. So that's the platform type. Down below is then our language type. And they're going to get the natural language PLTW version, not the natural language 2.0 version. So they'll want to select 2.0 Cortex and natural language. One of the things that you can tell if you walk up to a student's computer and they there's lots of like red X's and stuff going wrong. You know, one of the things that you can look at to see if they have the right language is just over here. It should say natural language. You know, if there's not a folder there that says natural language right off the bat, you know that something's not right. It doesn't have the correct library loaded. So at this point, what I would do is have them save, and obviously save as to wherever there's a location the students can access. If they just save, they're going to overwrite this template. If they compile that document, meaning they're having RobotC check the file, it's going to save over that template. So make sure that they change the name and save it somewhere else so that they're not saving over that blank template. All right, I think I covered the 5 steps there. Oh,
Hey, Adam, some folks would like you to email that out to us. Can you, that document you just showed us?
Sure.
Okay.
Piece of cake.
Thanks. I put into my lesson plans at least one day for tech issues. Like if half my class is up and running, then like that's a good day. And so it's just kind of a baby bird kind of situation because you can't, I have to fix like a Cortex at a time, and so it just, you know, if I can get 6 groups going or 7 groups going, then I can say, I just need you to walk away from your computer and your Cortex. I need you to go join that group of 2. You guys become a group of 4 for today while I try and fix your Cortex issue. But it's, you gotta be really well rested before this day happens, and just know that it just is what it is, and you just become better at trying things. But it just, I've never had a class where everybody's hooked that baby up and it's just flown. So just be ready for it.
So if you're working with your VEX, you have that breadboard that you already worked out that has like different motors and lights and different things here and there. And so your Cortex is hooked up to that, and your program is essentially saying turn on the light, turn off the light. You're kind of going through a diagnostic. So with the Fisher Tech, there is no breadboard, but you have the little, you plug it into the robo controller, and then it hooks up. Is it just hooked up to miscellaneous lights that are just sitting here and there, or do you put them on a platform, or?
You build each part for the 3.1 to 3.6. So the 3.1 doesn't have the test bed. So you'll build, they'll show you a little build that you're supposed to make. And so you'll build that little thing. And then from there, you'll go ahead and do whatever it says. But you don't have a big test bed like you do for...
you just use that black platform and you mount the stuff on that.
Yeah, and then you scrape it off and put it back on. Yep. Yeah, and so it's, I mean, it's a quicker deal. I'm the day I take to take apart stuff and the day I take to put stuff together makes me miss Fisher Tech.
And to prepare for this, you would recommend maybe that we sit down with, 1.1 all the way through 1.7, 6, whatever number it is, 3.1.6. And then just kind of work through everything that we're going to have the kids do it ourselves first?
Yeah, definitely.
Heck yes.
Yeah, because that's, I mean, you're going to experience the same problems that they have, if not, different problems that are going to help you when they have questions.
Yeah, and for the first, I don't know, I won't run through all of them this year, but probably for the first 3 or 4 years, I did them all each time.
Okay, so and then your kids are in groups of how many? Did we already cover that? Maybe 3 or 4 to a peak?
I do 2, and that's my personal opinion, that anything more than 2 is an audience and a worker, and I don't know who's working and who's the audience, but I only have groups of 3 if I have an odd number in my class, but it is my rule in my groups of two is that I have them alphabetically designate themselves as person one or person two. So whoever's first name alphabetically puts them as one, they are person one and two. And then I think everyone is drawn to a part of this. So like I have kids who love to program and hate to build. I have kids who love to build and hate to program. The love to build and hate to program folks, they get screwed because we don't actually test the building part. So I have a rule that I call it the driver, and you're the guy that touches the keyboard. So if it is an even day of the calendar, then you are, and you are number two in the group, then you are the only person that's allowed to touch the keyboard of the computer. If it's an odd day of the month, then you are and then person one's the only person allowed to touch the computer. And if I have a group of three, then we just make a plan for that. But then even if you don't know how to program, you at least were the guy touching the buttons while the other guy told you how to program. So there's at least some experience there. But I'm really cognizant, and especially at the beginning of it, I really am on it. I have 4 or 5 pairs of mittens in my room, and if it's not your turn to be on the computer and you will not keep your hands off of it, then you have to wear a pair of mittens, just because it's really hard to type with mittens on. And so, I mean, I have kids that just can't not control the keyboard if I don't have some sort of a reminder, and so maybe just, you know, a mitten on the hand they type with. But and so it's just so for me, I like a group of 2. Now, I will tell you that Project Leadway has it set up to where you have a group of 4. I personally think that it's impossible to do this with 4 people and have all 4 people involved. It's just hard to see the screen. There's not enough room on the plate. And so, but if those are all the parts you have, that's all the parts you have. And you just got to make the situation. And I happen to have bought enough extra pieces that I can have groups of 2. But it would be, in best case scenario, I would always have groups of 2.
All right, I threw out a number that's going to be helpful for those of you having connectivity issues or software issues, like whatever, your robot C is not opening or some sort of weird error or something like that. It's actually, they're in Carnegie Mellon University, which is Pitt, University of Pittsburgh. They'll basically direct you and help you to get connected. They've been really good about getting me connected. I've never failed with them. They're not a number to call if you're like, I have a program written this way and it's not working the way I want it to. They're just going to pass you off to the forum, which is a really good source. What I've recommended in the past, if you do have programming issues, whether you are still using RoboPro or Robot C, you know, screen capture the shot, email it to us, and we can kind of look at it usually relatively quickly and figure out what's going on, and then email you back. So it's another good resource if you're having issues. One of the last things that, 2 things here, I want to show you where the motors and sensors setup is, and then just kind of type a quick program, and then we'll let you go since we're pretty close here. There are some neat icons that they put up here. Where it used to all be was underneath this robot, but now they have this quick little shortcut you can click here. So essentially, when you plug in the motor and your potentiometer and your ultrasonic sensor on your Cortex, you have to let the computer know which one's which. And this is a really nice interface compared to, like, if you ever used Arduinos or used other microcontrollers. You know, you had to kind of set all this up. You had to set ports as inputs or ports as outputs, and you had to give them names and all that type of stuff. They kind of give you this little bubbly, gooey interface that all you have to do is type in whatever you want to call it, change the type, and it sets it all up for you. So there should be a couple of different tabs for you: motors, analog sensors, and digital sensors. You're going to find out that there's this thing called the motor controller that if you're in port 1 or port 10, it has a built-in motor controller where the rest don't. But you name it, for example, one of the motors that they have in the kit, in the Activity 3.1 through 3.16 is called write motor. So I named it write motor. One of the things that your students should get used to is the syntax, the way that they code when they're naming. Notice that I didn't put a space here in between the word, and the first letter of the first word was lowercase, where the second letter is capitalized. That's kind of like the space. It shows you the second word there. Um, One of the things I don't like about the way they do this is you would never write motor for your port name in real programming. It's too long. But as they're learning, they'll get better with this. At the beginning, they just need to understand that this is the right motor. So they can change their type here. It does not matter which one they click here. Every single one right here is going to be exactly the same as far as what's going to happen. The only reason why you would select a different one here is so that later on when you look at that port, you could say, oh, that's right. This was a 393 motor that I set up for high speed. So it just kind of changes the name for it. There are these things as you go across here. You can buy these little devices you put on the back of the motors. They don't come in your kits, so pretty much none and none is what they should be here. You hit apply, then I hit OK. You'll notice that up top here it built some pragma statements, and it lets you see that, hey, you have a right motor. It's in port 1, and this is what it is. It's a 393 high-speed motor. So it kind of lets you see that very quickly. If I go back up to motors and sensors, I can create an analog one here. Let's see, I'll put it in as a potentiometer. We'll call that pot. Apply, hit OK. Added that to my list at the top there. One of the things that you might want to do, but I wouldn't show the students, at least not at first, is underneath models. And this is even when we do the training in the summertime, because you want the students to be able to type in there and figure out where everything is. If you show them how to do this right away, they're never going to do this. But the platform type for our test bed, it already has everything named. We're supposed to name it exactly the same way and in the exact same ports. So if I hit OK, or hit apply here, it adds that test bed to my my file. Everything's set up this way, which is nice. The downside to it is it only gives you this at the top. It doesn't show you all the different pieces until you go back in and you select on motors, sensors. It'll show you what they are.
And also, they're not going to, it makes no sense for them to have something called right motor in their marble sorter. I mean, one that's called, mover or dropper or, whatever makes more sense. So I'm with Adam. I don't show that for a long time because I want them to know how to put their stuff in, because they're not necessarily going to use exactly what is in the test bed in their sorter.
So I'm just going to skip over the description and pseudocode for now. We'll kind of hit that up next time, but I just kind of want to show you how we build the program. So if you know the language, you can just start typing. But most of the students aren't going to know the language or have any clue what to do. So what's nice on the left-hand side here is that you have the library to work off of. And what you can do is expand these different things. Natural language is basically where we're going to pull most of the stuff from at the beginning here. So for example, if I wanted to start a motor for 5 seconds and then stop it after 5 seconds, what I could do is go into here underneath movement, and I can say start motor. What's really nice is I can literally click and drag this down. It lets me know that, okay, this is the start motor command. I need to put in what the motor port is. In other words, what did I name that port where the motor is connected, and what speed I want to put it in at. So if I double click motor port, I can start typing. I'm going to call it, well, that's the right motor. And then I need to put what speed I want it to be at. So I want it to be at a negative 127 to a positive 127. So it gives us our max speed is 127 one direction. Other direction is negative 127. Let's say I put in here 127. Okay. And then I want it to run for 5 seconds, so I need to wait. Again, I can click and drag that out. I can say wait and 5. And then I want it to stop. So I'll put in the stop motor command. Double click on that, type in right motor. And in this case, we don't need to put in a speed because inside of this language, there is actually the stop motor has a value of 0, so it stops it. And then what I would do is compile this, where I could go up top here and I could say compile program, or I can hit F7, and it's going to go through, check to make sure that the language matches what it's supposed to match. So if I, for example, put in here start motor, but I had a small m, and I compiled it, it gives me this yellow X. Doesn't like that. So it says that I'm substituting a variable here, and the yellow X will tell me, I accept it. It'll still work, but it's not technically right. It lets me know I have to go back in and change that. Change that, goes away. But for example, if I took out like a whole word, it didn't recognize this, and I compiled it, it gives me a red X, which basically says I cannot use this program. It's not written properly, will not run properly. So I have to go in there. They've gotten a lot better at this. This window down here, it used to just be jargon down there. Unless you were a programmer, you had no idea what it meant. So they've gotten a lot better at what they're writing. I go back in, fix what I need, compile it again, everything's good to go, no more errors. It's a really nice window down there to check. If I make that mistake, it tells you the line, it tells you what type of error it is, it gives you examples of what it's looking for. So it's gotten a lot better. All right, so next time what we'd like to do is, I'm not sure how many of you have access to Robot C at home, but if you can, get access to that. And what we'll end up doing is giving you a couple of practice programs and give you a couple of minutes to work on them, and then kind of show you an example of how we would solve them, so you can kind of see the process that we take to build basic programs.
And there's a question that I don't know the answer to, and that was, how long will they have access to our videos of these meetings?
Oh, I don't plan on taking them down, so they're on YouTube. I guess years, as long as they have the link.
Yeah, the cohort itself, that class, I think should last, well, they just cleaned out my last summer's class, so
Yeah.
I'm assuming it'll last until you get to your summer training, and then maybe you would add into a summer training course instead of the cohort, which at that point you probably don't need to have access to those videos.
Yeah.
But
Karen, somebody had asked a question about the Lego Mindstorms, and
yep.
So I am the third engineering teacher in 3 years, and I have the Fisher Tech. But apparently what last year's teacher did is I have 6 Lego Mindstorms with, I believe, NXT that are in my room. And so I guess I have 2 choices. One is Fisher Tech and one is Lego Mindstorm. And I guess at least with the Fisher Tech, I have files that are already there, and I really have not used either one of them. So I guess I would be interested in the Lego discussion if somebody else is considering that. I don't know how, I guess I know programming, but I've never actually programmed robots or motors or servos or things of that nature.
Well, there's tons of information out there for both platforms, especially Lego Mindstorm. There's lots of activities. But you are right there. It's kind of probably already has them set up for the Fisher Technics. I view Lego and Fisher Technics kind of the same level. You can do.
Drag and drop.
I'm sorry, I missed that.
Yeah, I agree.
Programming.
Yeah.
Yeah.
So either direction, whatever one you have more of, might work out for you. I think to me, really, it's not the platform that the kids are learning and what they're able to do with it, but they're learning the basic concepts of programming. How do I build a program, and how does this thing work? The different commands like, while, like looping, and, looking for branching out. So is this correct? Yes, go this direction. No, it's not. Okay, go back and do this. And you can achieve that with any of the systems.
You want to make sure that they know some language, that they have some understanding of language, because I know that there had been kind of a reprieve of language-based questions, and really there had been kind of a reprieve of control system questions on the final for a couple of years, where we're trying to do that transition between Fisher Tech and Bex. But usually the questions that I write from the end of the course take about 2 testing cycles to show up. And so I would assume anytime soon that that those questions are going to show up. So make sure your kids understand, Adam and I will talk you a little bit through, commands like loops and, whether you have a closed system or an open system, things like that. But just make sure that they are, if they follow through each of the activities and legit read them and do them, they will be decent programmers as long as their partner doesn't do all the programming for them. Okay, so Adam, we are on the 16th, and so
first.
So we're looking at March 1st for our next one. But if you guys have any questions between here and there, by all means.
How does Unit 3 go? So what is our pacing guideline for the rest of the year? Or is that too far ahead?
Well, what I kind of look at for me is like Unit 1, Unit 2, and Unit 3 are like, for me, like 85% of the year. They're basically the bulk of the year. Unit 4 ends up being a lot shorter, So, in fact, Unit 4 I've accomplished in 2 weeks, time.
Right.
When because typically in the end you kind of have to rush things if you don't have enough time, but.
So is the marble sorter the last big build?
There is a ballistics device, but as far as the Vex Fisher stuff goes, that's the last big build for the programming stuff.
Okay. Thank you.
You're welcome.
All right.
So Adam, what are you thinking meeting-wise?
Meeting-wise?
I think March. I think everybody's questions. The only one I couldn't answer was the how long would those videos be up?
Good. Yeah, I mean they're on YouTube, so they'll be there forever. It's just like the link that everybody's using to get to it. If they know my channel name or whatever, they can get to that as long as they need to.
I've not gone out and looked at how famous we are on YouTube. Okay. Like I said, I think the only one I couldn't answer was that one, but I think we got everybody else. And if you would send out that document you showed, I think that will answer.
Just send it out right now.
Awesome.
Because I would forget it if I waited till tomorrow. For sure.
I'd have emailed you. I'd have reminded you. You just got it. That's awesome. Very good.